Hi, welcome to Lesson 9.1. In preparation for Chapter 9, please go ahead and tear out pages 241 through 271. When you're ready, please make sure you continue the video. Now for Lesson 9.1, okay, you will need 1/2 sheet of paper, okay? And you're going to glue it on page 243, and you're going to draw a line right through the middle. And that is the only page that you really need to glue in this section. Now, on page 244, please make sure you write down where the problems are going to go. Problem 1 goes here. This is on page 244. Problem 2 goes here. Problem 3 goes down here. And on the next page, on page 245, number 5 goes right there. So let's begin on page 242. Now, there are multiple different ways to derive the Pythagorean theorem. So today's lesson is on the Pythagorean theorem. What you see here is a triangle with legs A and B and hypotenuse C. So what we see here is a combination of four congruent right triangles. So they're all pretty much congruent to each other. Now the side length is going to be A plus B and A plus B. Okay? All of these are right angles. Therefore, this is going to be considered to be a square. So we're going to look at the area in terms of the sum of all the polygons and the area in terms of the whole thing. So let's take a look at the area of the whole thing. The whole thing, the distance is A plus B. And it's the same for the other side. So in order to get the area of that, we're going to have to multiply A plus B times A plus B, or A plus B quantity squared. Now, based on what we learned back in Algebra 1, this is going to be equivalent to A squared plus B, A squared plus A times B, and there's two of those, so 2AB plus B squared. Now, that's the area of the whole square. But also, it is made up of the area of different little squares and the rectangle. So, of the square that's in the middle. So, the area of this white square is going to be C squared. Okay? Plus, now we have 4 of those triangles. So the area of one triangle is going to be the base times the height divided by 2. So A times B divided by 2 gives me the area of one of them. So I have 4 of them. That's why I'm multiplying by 4 here. If I simplify this, 4 divided by 2 is just going to give me a 2. So I have C squared plus 2AB equal to A squared plus 2AB plus B squared. I can subtract 2AB from both sides, and I end up with C squared equals A squared plus B squared. So this represents the sum of the legs quantity square equal to the hypotenuse square. Now this is true only when you have right triangles. And this is one derivation of the Pythagorean theorem. There are actually multiple derivations of the Pythagorean theorem. All right, so let's go ahead and go on to the next page where we actually glued a half sheet of paper. Now, what happens if we don't have a right triangle? What happens if we have an acute triangle and an obtuse triangle? That's why we're going to do 2 separate scenarios. Now, I already have a triangle that is already pre-made, and we're going to look into those. I'm going to give you all the measurements for them. Okay, so let's look at the acute triangle first. Okay. And the triangle is going to look something like this. So just go ahead and sketch it. It does not have to be even to scale. Okay, this is going to be 4.2. This is going to be 4. And this is going to be 3.8. Now the angles for this happen to be about 65.8, 55.4. Now the purpose of these angles is literally just so you can see that it is an acute triangle. Okay, so what we're going to do is we are going to organize the information that we have here. We're going to look first at the lengths of the sides. We have 3.8, 4, and 4.2. So we have 3 values. Now, the one that really matters here is the longest piece. The longest piece here happens to be 4.2. So that one will always be represented by the letter C, no matter what. Now, this will be 4.2. Now, a lot of people like to put A the smallest, B the second smallest. That's okay. You can do that too. So if we were to follow that, then this would be 3.8, and this right here would be 4. So if I was to look at Pythagorean theorem, we know that when it's a right triangle, you're going to have c squared equal to a squared plus b squared. But what happens when it is not an acute triangle? It's definitely not going to equal, but we need to look for a little pattern here. So what we're going to do is we're going to plug this in. We're going to plug these values into Pythagorean theorem. So that's going to be for C, we're going to plug in 4.2 quantity square. That box is going to be for my future inequality, by the way. 3.8 quantity square plus 4 square. Now we're going to use the calculator to figure out all these numbers. You know, let's work smart. So that's going to be about 17.64. Okay, 3.8 quantity square. It's going to be about 14.44 plus 16. Now, this is going to give me 17.64, and my sum here is going to be 30.44. So one of the things that you notice here is that the c square is always going to be less than your a squared plus your b squared. So in an acute triangle, you're going to have your c squared strictly less than your a squared plus b squared. So we can use this to classify if a triangle is a right triangle or not. If it's equal, then it's a right triangle. If it's not equal, will be acute or obtuse. If it's a less than, then it's going to be acute. Now let's do an example of an obtuse one so you can see the differences between those two. So I'm going to give you an obtuse triangle. Now I pre-made these triangles, by the way. Okay, the length of this side is 6.7. The length of this side is 6.5. And the length of this side is about 10.5. Now, we really don't care about the rest of the angles, but I'm going to put them anyways, just for fun. But don't worry about writing down the angles. Just know that this is indeed going to be an obtuse triangle. How do we know it's an obtuse? Because it has at least one angle greater than 90 degrees. So I'm going to do exactly the same thing. I'm going to pick my value for A, my value for B, and my value for C. So remember, the largest one will always be your C. So here the largest value is 10.5. Now the smallest value here will be A, which is 6.5. If you happen to mix these two up, it's okay. Just don't mix this one up. Don't mix the largest one. All right, so what are we going to do next? Same thing we did up here. We're going to check to see what is this going to be? What is my inequality going to be? So all we're going to do is substitute those values in. So we have about 10.5 quantity square. Then we have about 6.5 quantity square. 6.7 quantity square. So I'm gonna put these all in the calculator, and this should give me 110.25. 6.5 quantity square is about 42.25, and 6.7 quantity square is about 44.89. So you're going to add these two together, and I get the following: 87.14. So as you can see here, this is going to be larger than. So c squared is larger than your a squared plus b squared. So your c squared is going to be larger than your a squared plus your b squared. And this is going to be true when your polygon is obtuse. So if I were to give you the measurement of 3 sides of a triangle, you can automatically classify it by the sides. How? Simply look for the largest segment, that's your C, and then the other two could be either A or B. Once you do that, you are going to substitute the values in, and if your C squared is less than your A squared plus your B squared, it's going to be acute. And if it is greater than, then it's going to be obtuse. All right, let's turn to the next page. All right, so this brings us to our main theorem. In a right triangle, the square of the legs of the hypotenuse is equal to the sum of the squares of the legs of the length of the legs. In other words, c squared equals a squared plus b squared. That's the Pythagorean theorem. Okay, without the Pythagorean theorem, we would not have a bunch of different other theorems coming from them. Now, there are 4 different types of Pythagorean triples. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25. So what exactly is a Pythagorean triple? Okay, a Pythagorean triple is a set of 3 integers such that the 2 smallest ones added together quantity square, or quantity square then added together, I should say, should equal this one quantity square. So for example, 3 square, that's 9. 4 square, 16. 9 plus 16 is 25, which happens to be the same as 5 square. 5 squared, that's 25. 12 squared is 144. 25 plus 144 gives me 169, which happens to be the same thing as 13 squared, and so on. Now, any multiple of these right here would be considered a Pythagorean triple. For example, here you can see that if you double this amount, all these 3 numbers, you get 6, 8, 10. If you triple it, you get 9, 12, 15. You can multiply by 4, 5, 6, 7, 8, a million, and there are technically an infinite amount of Pythagorean triples. Okay, so any multiple of these 4 main Pythagorean triples are going to work pretty much. All right, next page. Page 245. The converse of the Pythagorean theorem. So if the square of the lengths of the longest side of a triangle is equal to the sum of the squares of the lengths of the other 2 sides, then the triangle is a right triangle. So it works backwards. If your c squared equals your a squared plus b squared, then it's going to be a right triangle. What happens if it's not? Well, this is why at the beginning of the lesson I showed you guys what happens if it's not. If your c squared is less than your a squared plus your b squared, then it's going to be considered to be an acute triangle. If it is greater than, if your c squared is greater than your a squared plus your b squared, it's going to be obtuse. The only thing you have to remember is that c is the largest length. It's not just any random ABC. C has to be the largest length. All right, let's go ahead and start our first example. Okay, so here is our first example. Example number 1. It says find the value of x and tell whether the sides of the then tell whether the side lengths form a Pythagorean triple. That means that I'm going to be able to figure out what x is. And if x is an integer, then it will be a Pythagorean triple. So one of the things we have to remember is what is A, what is B, what is C. All right, always remember that the right angle is the one facing the hypotenuse. So the hypotenuse is always the largest side, which in this case happens to be x. So remember Pythagorean theorem. C squared equals A squared plus B squared. Now in this case, C is going to be x because that is the hypotenuse. So that's going to give me x squared equals, now here I have the choice of either having this one A or this one A. It doesn't really matter. The one that matters is the hypotenuse. Now if you want to pick the smallest one to be A, go ahead. You can do that. You don't have to, but you can. So A is going to be 5. We're going to make that one A. We're going to make this one B. Substitute the values in. That's 5 squared plus 12 squared. Mental math here. 5 squared, that's 25. 12 squared, that is 144. Combine those together, and you get 25 plus 144. And I get 169. Now, to solve for x, you have to take the square root. So x is going to be the square root of 169. In your calculator, if you have one of these, type in your 169 and then type in this key right there. In some calculators, you have to type in this key first and then type in the number. So know how to use your calculator. Now here, the square root of that of 169 happens to be 13. So 13 is an integer. Okay? So in this case, 5, 12, and 13 are a Pythagorean triple. Can't spell today. So how do you know if it's not? If this becomes a decimal, after you take the square root, if it's a decimal, then it's not a Pythagorean triple. All right, so that's example number 1. Let's look at example number 2. Find the value of x and tell whether the side lengths form a Pythagorean triple. All right, so same thing. We're going to do c squared equals a squared plus b squared. Remember, first thing we need to pick is our c. Here's the hypotenuse, and the one that is right across from it, I'm having a hard time drawing an arrow, the one that is right across from it is going to be your c. So that's going to be c. These two could be either a or b. It doesn't really matter. All right, so we're going to have 14 squared equals, now, like I said, it doesn't matter which one you put. If you have this A and this B, you're going to get the same result. 14 squared is going to be equal to x squared plus 7 squared. Now, ladies and gentlemen, squaring does not mean doubling. Okay, 14 squared means 14 times 14, which is 196. So I get x squared plus 49. You minus 49 on both sides. And you get 147 equal to x squared. To solve for x, you have to take the square root of 147. Now, when I put that in the calculator, you notice that I don't get an integer. So to the nearest tenth, x is going to equal approximately 12.1. And I should really be careful. I should not use equal sign. I should use an approximate. Anytime we're rounding, we got to use an approximate. So since this is not an integer, we can say that these values, the values are not a Pythagorean triple. So not a Pythagorean triple. Okay, so not a Pythagorean triple. All right, so that was example number 2. Let's look at example number 3. All right, so here we have an application. Let me zoom in a little bit so you can see it. The skyscrapers shown are connected by a skywalk with support beams. use the Pythagorean theorem to approximate the length of each support beam. So in other words, they want me to figure out, okay, what the value of x is going to be. Now, according to this diagram, 23.26 is the length of only one part of this. So if I were to redraw this right triangle, okay, I would have 47.57 centimeters, okay, centimeters, ooh, we're kind of small, and 23.26 meters. Where did I get the centimeters from? I don't know. Meters. Okay, and we are looking for the value of x. Okay, so for the value of x, we are going to use the Pythagorean theorem. Now remember, C is always the one right across the right angle. So in this case, C is represented by my x here. So C squared equals A squared plus B squared. C represents x. A, it doesn't matter which one is which, okay? So I'm going to make my A 23.26 quantity square and my B 47.57 quantity square. Now, you definitely have to use a calculator for all of this math, okay? Don't try doing this all by hand or you're going to go crazy. You're going to go loco if you do that. All right, so 541, whoops, excuse me. 541. Now I'm going to round to the nearest, probably to the nearest tenth. So in this case, it's just going to be 5.41 because if you notice that I got 41.02. So I'm just going to leave it to the nearest tenth. Sometimes you're just going to have to do that. Now 47.57, unless they want an exact answer, you know, type in the whole thing. When you square it, whoops, 47.57 quantity squared, it's a large number, guys. 2262.9. Okay, look at the big number that I got. All right, so we're going to add those two together, and I'm going to get x squared equals 2,803.9. Now I could just leave that number, and then when I take the square root of that number, 2,803.9 square root to the nearest tenth should be about 52 point. Now it says 95. One of the things that I'm noticing here is that all these numbers are to the nearest hundredth. So I'm actually going to leave this to the nearest hundredth. Now, if your answer is a little bit off, it's okay. Pick the answer that is closest to the real answer. Okay, so that was example number 3. Okay, example number 3. Now, we are skipping example 4, and let's jump right into example 5. Example 5, it says, verify that the segments with the following lengths form a triangle. And is the triangle an acute triangle, acute, right, or obtuse? So one of the things that we didn't check for, and I forgot to do it on the lesson, is how to verify if it is an actual triangle. Okay, you got to think that the two smaller sides has to be bigger than the large side to check to see if it's an actual triangle. So let's put these values here in order, or actually they are in order. So A, B, and C. Remember, the largest one has to be C. And it just so happens that 6.1 is the largest one. Okay, so 4.3 and 5.2. So first thing, let's check to see if this is even a triangle. So what I need to do is I need to add my two smaller sides and check to see if it's larger than my third side. If this is true, then this is going to be an actual triangle. What kind? I don't know. We haven't decided yet. So let's do that. 4.3 plus 5.2. Okay. Will it be bigger than 6.1? That's going to give me 9.5. which is indeed bigger than 6.1. So it does check. It is an actual triangle. Now what we have to do is check to see what kind of triangle it is. So let's check that. Okay, so when we do that, we are going to plug that in to Pythagorean theorem. But we don't know whether it's going to be greater than or less than. We don't know that. So we got to figure that out. So that should give me 6.1 quantity square. Okay. A should be 4.3 quantity square. B should be 5.2 quantity square. And all you have to do now is calculator. Okay. So when you do that, you get 37.21, 4.3 quantity square, 18.49. If there's not that many decimals, guys, just put the whole thing. Okay, 27.04. So combine them together. Okay, so when you combine them together, I get 18.49 plus that. All right, get 45.53. So now we have to make the determination. Is this going to be less than or greater than? In this case, 37.21 is less than 45.53. Which, because this is less than, that means that this is going to be an acute triangle. Because if you remember, in an acute triangle, the c square is always less than the a square plus the b square. Okay, so if this were to have been greater than, it would have been obtuse. If this was to have been equal, then this would be a right triangle. All right, thank you for joining us today, and we will see you later.